Another common question in the Officer of the Watch exam is please explain a star delta starter. So here we're looking at a star delta starter. We walk through the circuit. We have a fused circuit breaker, three sets of contactors, the motor and the overcurrent relay. And then on the control side, this is the supply voltage, which in practice is usually taken off around here. This goes through a fuse. This is a transformer and another fuse. This now steps down to a lower voltage, which is safe to be connected to control and instrumentation devices. So let's walk through the system, starting the motor. So first of all, important to note is that circuit diagrams are always shown with power off, and this is shown with power off and everything in its open position. So the first step would be we would close the circuit breaker. We close the circuit breaker over. Now this is closed and these remain open. Now in order to get the motor to run, we need to supply it with current. We do this by pressing S2, and then this closes this circuit. If we follow round, this is now closed. This is energized, which is a contactor. This closes this contactor. Also, this side is energized, KM2, which is the main contactor. So what that means is now we have supply current coming in this way, coming out through the overcurrent relay, and then through the KM1 contactor. What we see now is the motor is connected in star configuration. This is the start point. Now after a delay, we have a changeover. So KM1 will open and KM3 will close. This is denoted here. This shows a mechanical link. When this opens, this closes, and then KM3 will come in. And then the motor will be operating in delta. The reason for this is that in the star configuration, we operate with 1/3 of the voltage, which is advantageous for inrush current. We have a lower inrush current, so that means that we don't have to have such large cables to deal with such a current. But with 1/3 of the voltage, we also only have 1/3 of the torque. Now, if this was to be run for an extended period of time with 1/3 of the torque, we would end up in an overload situation, as the motor will be matched to a given load, and effectively we are now 66% underloaded. So we must change over, and we do so as described in the control circuit. And then we've gone through that band of inrush current, the motor is up to speed, and then we have full torque available.